Hello and welcome. I'm Justin, and I'm kicking off a series to share the game dev sacred knowledge that I've learned over the past 5 years through the various iterations of my game development, that we can work together, optimize our development, share solutions, and make our dream games a reality. Alright, so in the spirit of system building, like we were talking about earlier, I want to talk a little bit about the systems that I started to build in my game. So this is something that I feel like it's pretty neat. I had this idea that making these videos, the problem for me is that I really don't know anything about video production. I don't know how to use Adobe Premiere, I don't know how to use DaVinci Resolve or anything like that. But the idea hit me where I'm like, okay, maybe I don't need to. Maybe I can just use the game runtime framework that I put together in conjunction with my tools, and I can maybe just use that to render out and create this whole video production for this series. And a little bit of work went into it, but that's exactly what I'm doing. So basically, the videos that you're seeing are entirely made within the game framework. So just to speak a little bit to the importance of good system building, you want to have a nice versatile system that will lend itself to anything that you're trying to do. Basically, I was able to just take what I had already written for my game in this MonoGame implementation, which is primarily with this piece here, this component. This is, I called it a runtime subsystem. That is like the poorest naming I've ever done. But that essentially just controls all of the entity component system, ECS, that I've come up with, instantiates everything that's needed, and lets us get started quickly with the actual runtime so we can leave our game.cs, and that's specific to MonoGame. But you could use this same sort of principle for Unity or, Unreal, which I haven't used Unreal, so I'm sure it's going to be quite similar, with some differences, depending if you're going like Blueprint route versus native C++. But in this instance, since I'm strictly code here in MonoGame, it just made a lot more sense to create this separate object that would just handle the whole runtime for me. And then what I went through and did was, I first tried to use MonoGame's video player, and I hate to say it, but it's pretty basic, and honestly, it just didn't even work. On Windows, I think it just can't read an MP4 file, so it just was strictly looking for a WMA, like a Windows Media file, because like again, this is the XNA framework, sort of graduated from Microsoft, and the open source community picked it up. It's something that I started on like 13 years ago. I absolutely love this. It was fantastic then, it is still fantastic now. The cool part about it is since it's all just native C# and that video player wasn't working out for me, I just hit the NuGet package manager and just started looking for useful tools, reputable tools, before I started delving into other custom implementations, so that I can start to render videos in my MonoGame runtime. And then I found it. I found VLC Media. I found this library that they produce for C#. So, a little bit of hitting the documentation, a little bit of complicated things, because it's like a C++ interop kind of thing. So, there's things happening in your C# application, but there's also things happening in native C++ wrappers that it's going to initialize. And I couldn't really find any documentation online about this, so for anyone who is using MonoGame out there and you are looking to implement video playback in your games, I have come up with a very elementary beginning type of implementation that will work for you. So it just uses these two primary objects here, the libVLC object, which basically just defines the wrapper around everything to get that runtime started. And then the media player, which, I mean, you could probably assume what that is. That's essentially a cross-platform implementation that will help you with all the functions related to the media player itself, like loading content, playing, managing the state of it. And mind you, this code isn't, you know, it's still slightly ugly. You know, I was talking earlier about, you know, you don't necessarily want to make all this spaghetti code that is difficult to maintain, and you want to build good tools around that, but my tools are not yet fully in commission, since I took a break a while back. But essentially, I got libVLC to work here, and all you have to do is initialize a libVLC object, and you can just pass it basically like command line parameters that you'd be passing it. I'm not actually sure that I need to pass these in here. I think it will auto detect what the best option is, but I did anyways just to be sure. And which is to explain the options. It's just basically telling it to do direct 3D. Specifically here, the video out. It's just saying, hey, use direct 3D 11, so that, because I know that MonoGame in my current instance is using DirectX 11, so let's use that. Again, I'm not even sure if that's needed, but I figured I'd put that in there anyways. And then here in load content, we basically initialize the media, and you can also set this dynamically. It's not like this has to load it into memory, I don't think. Not the whole video that you're referencing. Obviously, it's going to stream that, but it will set up that media so that it can be used by the media player. And then we set up a media player object and then configure the settings. And this is the most important settings here, is the enable hardware decoding. I mean, you could probably leave this to false or true. I don't think that one matters too much. But this one is the #1 key. And I haven't come up, I've tried to do the other methods so I can still display stuff from MonoGame and my sprite batches on the screen, but I just could not get that to work. This would require you to use a swap chain render target, which is probably the least talked about thing that I can find on the internet, specific to MonoGame. And basically everything else that's like, if you're going to try to take VLC's media output, because it wants to push its own content at its own internal clock rate, if you want to take that content, you'd have to put it into a memory buffer, and then you would have to write it to a texture in C#, and then write it to the screen. So it would be slow and unruly. So what I ended up doing here was I have a DirectX window, which is managed by MonoGame, the game window. And so I just give it the window handle. And that's something that the media player wants or needs. If you don't provide a window handle, like the pointer to the window, it'll just create its own. It'll bring one up. Yeah, that was less than desirable in my case, because, you know, it takes you out of the game basically and then brings up a whole separate window. Not ideal. So by setting this window handle, this will basically tell the media player that it should be using DirectX, and it should write directly to the DirectX back buffer of that window handle. So we could definitely talk about some of the other options that I've tried so far, but I only put a couple of hours into this, and I got this to work after trying the swap chain render target and being pretty unsuccessful with it. Basically, we need you to have like a separate window that you're not displaying, where this would be rendered, and then you would be grabbing that, and then you can have that as a render target to to write to the DirectX back buffer. And that's just a mouthful for saying, set this one parameter, and VLC Media Player will do the thing. And then just talking a little bit about, you know, what we see in the actual video production. I have a lot of rough code in here, but I just really did want to just rough it in over the past couple of days. I just had this idea like, okay, I can make this video production within MonoGame, within my game tools, and use my existing ECS system to, you know, handle screen transitions and different things like that between video clips. And so at the beginning, you see these particles floating up and they're like bouncing off the top like a water effect. That's exactly what it is. I've set up an entity. I've set up an entity base, and that entity base is part of my ECS, and it basically just defines an object. Again, we can attach components to that have behaviors and things like that. And I'm attaching a component coming from a testing factory. Another part of this, since my tools aren't done, I've statically created a bunch of functions that will create the data objects for me. I can't, since my tool isn't ready, I can't import those as JSON strings. So I am sort of manually doing it by hand and instantiating it, but at least I've proven out that it works. So yeah, basically I just have this set up to create a particle system, and we can just jump over to what that looks like as soon as this loads. It's using a bunch of different, of these data models, and I'm just basically defining a particle system. This is something that my tools will do for me, so that I don't have to manually create all these objects by hand. I guess there still is some level of creating them by hand, but in the tools you can obviously expedite a lot of this process, or it's just at least a lot more user-friendly to create and maintain everything. Basically, I've just created a particle system, used emitters, and this particle system, honestly, function-wise, it's oddly similar to the one that's in Unity. It's based on the Mercury particle engine, and it comes from the MonoGame extended package. And, I basically just took all of its different parameters and put it into data models that I can use from the tool to just define everything a lot easier. And it takes a list of particle emitters, the particle system does, and the emitters is actually what's going to, emit the particles onto the screen and manage all that stuff during runtime. And so the water itself is just going, being generated by this. It's not actually using a texture, it's just creating a 1x1 pixel square texture in the background manually, just setting that pixel to white. And then I can just color it, work with it any way that I'd like. And yeah, it's pretty straightforward, honestly. And I've just defined these data models, and maybe it would help to just look at what one of these data models looks like. These, of course, have a lot of fields for the particle emitter. I couldn't really think about a useful or effective way without using like my dynamic variable collection to set up all these different things and serialize them. So I just like, whatever, I'll just make a massive data object for it for now. Everything else is pretty streamlined, but this one's a little unruly because there's just so many options, because it's a particle system. But I basically went through and defined everything that the Mercury particle system offers, compatibility-wise, or whatever you want to call it, from the MonoGame extended package. And then that gets translated within an actual component. This goes into our entity component system, and the component itself is going to define the real deal, basically. So like there's the data models that you do for your data-oriented design, and you would be able to create those anywhere. They're just what we'd call POCOs, plain old CLI or CLR objects. And those objects we can serialize to JSON or whatever format you'd like, and work with them a lot easier than this. This is like a real runtime object that reflects things within your game engine that you're using. So that model, that data model will just get attached here, basically just by using one of the constructors. And then from there, the ECS that I've come up with, and I still have some revisions to do on it, but it basically defines a really simple thing, like all components, they'll be able to reference the parent that it's attached to. This is probably going to feel pretty similar, if you're familiar with Unity, to the game object paradigm that they have, where you add components to a game object, which is, this is what's causing me to think, like, I think I need to revisit this so that I can optimize how some of the systems will process all these entities, rather than giving them all direct access to the functions of, update and fixed update, but we'll revisit that. But it essentially just gives each component the different hooks into the life cycle, so that whatever code we need to run, we can run that as needed. And there's an initialize method that goes ahead and actually creates a particle system, and it creates it and say that this has some hard-coded effects here that I am not. Oh, that's why. Yeah, I sort of made this janky for now because I was just trying to get it done quickly. So if the model is not null, it will run this other method where it'll actually configure the particle system from a model. And that basically just goes through this process of go through the particle system, set all of its data to the data model, and then it goes and adds an emitter. And this basically, like what I'm outlining here, is basically how everything in this ECS functions. You could replace this from a particle emitter and system to a sprite renderer or a physics component. Like whenever we add those things from a data model that it's attached to our entity, we are basically going to need to, I get the right word, like hydrate or translate the data model into an actual engine runtime object that does something. And so that's what this process is going to look like pretty much across this entire ECS within my game framework. And so this just goes through the process of adding an emitter into the particle system, and it just loops through for every emitter model that we provide. It will create an emitter for it. And that ultimately, to keep a long story short, that ultimately gives us water, essentially. And it's all because of the way that it's defined. The particle system provides a lot of different configurations for how the particles will behave and how they get emitted. And so that's just using a technique that's box fill, and it keeps them within the box. And as it all floats to the top, because it has a gravity modifier on there. Of course, I picked the most complicated thing to talk about, but particle systems, they're pretty complicated. But yeah, basically those particles will just rise to the top, and then they'll just be bouncing off the top. It gave a really nice looking water effect, so I was like, cool, call that water. And so just creating this entity base, calling it water, attaching the particle system component to it, giving it a size, that's just the parameters, arguments that function takes. And then the logo that's on the screen at the very beginning, I don't know why there's extra space in here, but the logo, another entity that is physics-based, which, if you recall from the beginning, at one point it just sort of falls down out of the, further down this, down in the water, if you will. And so that's all controlled here through that. And I did have to go like the long-winded route, because again, my tools aren't up to date. I have to revisit all that development and refresh that. So I just wanted to do this all by hand, just to get something started. But I've just gone through and attached different components to it, so a sprite renderer, a physics component, and load the actual texture. And then we also attach different data to it, and a light. That's what sort of lights the scene at the beginning. And as we go through this whole process, and it also puts a particle system on the logo itself. See any particles, moving towards the center. Just another behavior of that Mercury particle system, just as defined as data. Basically, just came in here and was like, all right, well, we'll have them spawn in a ring formation so that it spawns on the periphery of this system, and then all those particles will go towards the center. So pretty simple stuff. Just defining everything as data makes your life a lot easier again, and building robust systems just takes you to the next level. And then here's part of that dynamic data system that I was talking about. This allows us to just set variables into a large collection, and it maintains them by type. So we can basically put things into, got different types, several overloads for this function. I could also make it, have made it a generic type to just say like what type this data is going to be that I'm putting in. I'm still pondering on the implementation because I put this together pretty quickly for my 6th iteration of starting over from scratch and leaving Unity. So I'm still in progress. But this is essentially just going to configure different components. So see this like dot notation. You know, the dot probably isn't necessary, but it certainly helps to keep things more logically oriented. You know, all these variables are being held at the entity level, and then the components that are attached to the entity, if they care about it, they will reach in and listen, you know, read these values. And this is just saying, you know, physics rotation speed is 0, physics affected by gravity is false. You know, renderer scale, so like whenever the logo is coming in at the very beginning, it's setting the scales to 0, and then it sets a scale speed for how fast it should scale up. And then finally, we just add these entities to the entity collection. So pretty straightforward, and this is all provided by that runtime subsystem. So whenever I started this new project, you know, a completely separate project that's not where my game lives, because I just wanted to keep this video production stuff separate. Yeah, I was able to just get this stuff done quickly, just in a few hours of, you know, thinking about what it should look like, putting the code in. And it certainly took a lot less time than me having to learn Adobe Premiere, as a perfect example. And then getting into, you know, some of the more interesting nuts and bolts is the timeline. So this is like another construct that I've come up with for my game. And this is essentially going to control data in motion, like a lot of other things within my framework. And this is just defining different points on a timeline that things should happen, which was, this is a perfect structure. I'm going to use this in the game, in my game, to control different events in the game world. Also to help facilitate story events. And, you know, the implementation is pretty loose, it's pretty versatile. Like, you can either strictly define a duration that something can take, or you can give it conditions to say that, okay, well, this timeline item won't be completed until these conditions are met. And it can also send messages, which is basically sending data. This is like the data in motion aspects. So whenever I first start this application, and, you know, the logo is going to start to pop in, because it's based on this message data here. It tells the logo that it's going to increase its light intensity and the width of the light, and it also changes the render scale to 1. So that's why, you know, as soon as this starts in the beginning of this video, the logo sort of just starts to gradually grow. Same with the light around it. And that's also what, you know, cues up a sound for the mixer to play. And so these are just some messages that will be, you know, sent to the objects that we have listed as the target name and the message recipient type. You know, it's a named entity basically. And yeah, this will just send it directly to those entities, and then they will have a message queue in which they process all this stuff. So yeah, pretty straightforward. But that's that data in motion aspect, where I want to define behavioral things without writing code. And so that's essentially what this is accounting for. And so we have a couple of those introduction slides, you know, as things are moving around, text is being populated onto the screen. Logo, we're changing to certain aspects of the logo. Let's see if I can find some of that here. We're updating HUD information, basically just by, you know, again, picking out the component that it should care about and the data that it wants to do something with. I'm basically just telling, you know, the top banner is going to queue this text, and you know, there's a text queue system in the HUD. I know, like, this is super expansive, and I'm definitely gonna have to make additional videos to talk about everything in depth. But it is super expansive because of all those iterations I've gone through, and feeling the pain of hand building a lot of this stuff in Unity, like hand building user interfaces. I was like, oh, this is dreadful. I would really like to make this a lot more dynamic. And so that was, you know, what all these efforts led to, was just a better understanding of how I can make all this stuff more generally applicable and apply to my game at large. And obviously, you know, proving to myself, it's like, okay, I've definitely made it pretty generally applicable because I've turned it into a video production suite as well. And then as we continue, I think the most neat thing is going to be to look at and picking back up on the VLC topic. as we are going to queue up our first video. And here's where, the time doesn't matter, so I just set it to 1 second, but it's not even going to look at that because we have a condition set. And the condition is while the media state is set to playing, we're going to stay at this timeline item. And then this is data that it applies when the timeline item reaches, starts to execute. So it basically sets the media URI, and it's going to load up an MP4 video. So one of these videos that I've recorded already. I'm going to load that up into one of those VLC media objects, and media.play, true string, it's just going to tell the media player to play. That one's pretty self-explanatory. And then these ones is going to let me to, video production suite style, be able to configure a start and stop time for the video, so I don't necessarily have to go through and edit all these clips or create clips. I know that's not super efficient, and I will probably gonna come up with a better way. But this is working pretty well for now. I can just set a start time and an end time within the media that I load. It'll seek to that position once it starts playing, and then once it reaches the desired end time of this media, based on this variable, it'll stop the video and progress into the next part of the timeline. And then finally, it just automatically sets this data. So I didn't trying to make this external interrupt thing with VLC work with my system well. It's easier for me to just make up this variable instead of it being based on the actual status of the media player, and then we can just set this accordingly. So as soon as this timeline item starts, we'll set the media state to playing, so then we're stuck in here. And then once the media actually stops playing, it'll set this data to a different value. It'll set it from playing and change it to anything else, basically. And then that will exit this successfully. So basically, as soon as we hit this end time, it will set that to something else, and then the condition will no longer be true, and it will move into the next chapter, next item. So that's basically, the long and short of the implementation so far. And it's just been a super, super big blast to make all this. And then, our update function, here's where some of that magic is happening, where, if the actual media player itself is in an ended state, we tell it to stop the media. And that essentially just stops writing to the DirectX back buffer, and then MonoGame can come back. That just tells it to stop, and then we just tell the entity that the timeline component is attached to, which is the HUD, the user interface. We just set that media state to stopped. And then from there, it'll exit and keep on moving across the timeline. So now, I don't necessarily have to go through and program all these, start and stop points, or, bust out the calculator and figure out this clip ends at 47 seconds and then we'll start doing something else. No, this is going to be nice and dynamic, so I can just keep adding on to that timeline and it will manage itself, which is just great for, again, I don't want to learn Adobe Premiere yet. I just, I want to keep my focus and energy on building my game and building this, shareable content. And this was just a great way for me to do that. And yeah, and here's just listening into some of these variables. Probably a very poor performance method of doing so. This variable collection, it's a dictionary, so it's stored in a reasonably fast data structure. We're looking it up directly by its index, so it's reasonably fast. It's reasonably fast, and for just trying to make my video production stuff quickly, this was a great solution. So this just controls, the different, once this variable gets set, then this will start the media player and load the media. Yeah, this just makes my life a lot easier. Queue up the transition, which is a shader effect, so it'll just set a parameter so the shader can respond correctly. Yeah, and so overall, it does make life pretty easy. And because I've gone through the process of abstracting all the more complicated things away into that runtime subsystem, which encompasses everything that my game, like my actual game needs, like the loading of content, the initialization of entities, adding entities, drawing them in the correct order, with HUD and lighting and all that stuff. But like that all gets taken care of by the runtime subsystem, so quality system building. So that a great effort right there, and that helps to make great games. Because of course now all that stuff is abstracted from me, so as I'm building other content with it, this is all I have to do. Runtime.draw. Perfect. That does make it very easy. Same with up here, runtime.update. Nice and simple. And you know, if there's an interest out there, I can talk more about those systems that I've implemented. There's one for the runtime management, there's one for the environment management, the display management, like the actual graphics properties of the screen. There's also one for physics, so if anyone's out there curious to implement physics with MonoGame and create yourself your own fixed update loop, would be happy to talk about that. You know, certainly just leave a comment and would be happy to dive into it. And so I just want to now show what this looks like in practice. So, you know, we've defined all the data by hand. Not my best moments here, but once the tool is back up and running, I can just create all that stuff in my user interface, and then it's a lot easier to manage, and then the code is even cleaner. I wouldn't have to define any of this stuff here. This would just load an asset collection, and boom, video to the screen. But just to show what that looks like, because I just think this is super, super fun. Loads everything to the screen, the same type of video introduction and everything that is in this series. All done and made with MonoGame, with the same framework that I'm building my game with, because it makes a lot of sense. It makes a lot of sense, you know, instead of having to learn After Effects and a bunch of cool Photoshop tricks with Adobe Premiere and the Adobe Creative Cloud. Wow, you know, it's like, why bother with all that when I can just use my game tools and my framework to do all this? It just made a lot of sense. And so here we are. You know, the framework and the systems building, which takes a lot of time and planning, it'll pay you some dividends that are absolutely worth it. Welcome. So, yeah, absolutely worth it. And I'm just extremely pleased that I was able to get the VLC media player integrated here. Some limitations, like we talked about, needing to use the window handle and whatnot. But overall, you know, that's like a light introduction to part of my game's framework in ECS. Yeah, that's the versatility of building quality systems, is that you can use them in a number of ways, and it will treat you well no matter what you're trying to build.